Hello, everyone. And now we are moving to the presentation from Martin Wanjiru, right?
Yes, yeah. Wanjiru.
Okay,
yes.
Thank you. And Martin is going to give a presentation about a first step from Ad-hoc Sql to Scalable ETL. And Martin is a data enthusiast and is currently working as a data analyst at Apollo Agriculture. And Martin, you can go ahead. Thank you.
Okay. Thank you for the introduction. So as he said, I'm going to give a talk about how you can move from Ad-hoc SQL to a Scalable ETL. And also a very brief introduction about myself. My name is Martin Wanjiru. I have a background in mathematics, and I am currently working as a data engineer at Apollo Agriculture, which is based in Nairobi, Kenya. So I'm going to give you a background about the company and why data is so important to the company where I work. So the company started back in 2016, and when it started, this is the puzzle that was presented to our founders. They compared farming, subsistence farming in Africa and commercial farming in US, and they were trying to look at what amounts to high dollars per acre earned, and this is the financing, farming inputs, advisory, insurance, and market access. And it was evident to them, and as it is on this slide, that the African farmer has limited access to this. And now this led to the birth of Apollo Agriculture, which comes in to finance the farmer, provide the farmer with farming inputs, advisory, insurance, and market access, and bundling all this together for this farmer in rural Kenya and giving them the chance to increase the amount they earn per acre and make them compete with farmers, fairly with farmers in Kenya and across the world. So how do we exactly do this? So we have set up a very nice sales process that starts up with the farmer signing up. So the farmer will hear about Apollo Agriculture from another farmer or from an agent or from radio or from any other marketing channel we have set up. And after they sign up, they will be onboarded into Apollo Agriculture. We collect here at this point, we will collect all the information that we need. We'll collect KYC. We will also collect information that we need for our credit models. And after that, we do a credit decision on the farmer, and if the farmer is approved, they go ahead and pick up farming inputs from a local shop around them. And then after the pickup and after the farmers have gone on and planted, we continue to give them digital advice through their phones, and we help them set up repayment plans that so that it becomes easy for them to pay to pay back the loan in the long term. So given this sales process, what does that mean to the team, the BI team that is responsible to provide data to the other departments in the company? It puts BI at the center of all departments in the company, from call center to field operations, finance, logistics, and collections, because all these departments are highly data driven and they want to make informed decisions. So BI serves all these departments by providing accurate data to help them make informed decisions in their day-to-day operations in the business. So therefore, for BI to start, we had to start somewhere, and this is how we started. We started with using redash, which is a lightweight dashboarding tool that allows you to write SQL queries against your database and visualize them, and also allows you to use parameters. So we started with redash running on top of our production database, and at this point, it was only the CEO who was doing all the BI work, and it was really working. The data volumes at that point in the company were very small, so it was not hard for us to continue to run these queries on top of our production database. But as we continued to grow, we then moved from running on top of the production database to creating a read replica of the production database and running queries on top of that, which was still working, and the switch really improved performance. And the company continued growing as shown on this chart. This chart here shows how the number of farmers who are working with Apollo have grown from 2017. And at this point, it was all the BI work was done by our CEO. And then around, as the growth continued, around the third quarter of 2018, we had our first BI hire, and the second and third in the end of 2020. And so this growth are shown on our next slide. So when we continue to grow in the number of customers, when we continue to grow in the number of engineers who are building features to in our sales channel, when we continue to venture into new products and to go into new territories, the setup we had for BI was starting to have problems with one, speed. Our dashboards were starting to become very slow. Second, accuracy. Dashboards have started to become very error prone. It was very easy to make a mistake and not notice it. And third, the onboarding process was very hard because there was no proper documentation. So getting someone else new to join the team was very hard. So, and expounding more on the problems that we had. One, we found ourselves writing long and very long SQL queries as shown here, where we have more than 539 lines of SQL. And these are nested CTEs and subqueries. So it was very hard for someone to come in and read these queries or debug them. Also, redash allowed us to use to do query composition, where the results of a query would be used as the in the from statement of another query. So queries would be referring to other queries, and this got us to in a very sticky situation where debugging was very hard. We were also copy pasting code a lot because we have a piece of code that defines a business logic that you want to use over and over again. So if you copy paste that in your queries and the business logic changed a little bit, then you had to update all of them. And first of all, even tracing them was a problem. So these are the problems that we started hitting, but the setup was still working for us. But so we took a giant step back and started thinking about what we want to do to improve this process. And one, we wanted a better code review process. We wanted to be able to have peers review code in the team. Also, we wanted to have proper documentation of BI code so that it was very easy to explain the code we have, and it was very easy for someone else joining the team to be able to go through the documentation and actually understand what we are doing. We also wanted to have a version control where we know when code changed and why it changed. Then we wanted to build testable and scalable models. And then we had gone through Rapkin post-dimensional modeling, where we have a facts table surrounded by dimensions, and we wanted to model our data in this way so that we could improve our reporting in the warehouse. So this being what we really wanted, we needed to make decisions on tools that we want to get for us to do this. And we had to choose a database, and we went for a very unusual choice for our warehouse, where we chose a Postgres warehouse. And this was mainly because of the fact that we were collecting GIS data, which we could, at that point, we had no other database that was processing GIS data as good as Postgres was for us. So we had to go with Postgres, and going with Postgres also meant that we did not have to change the SQL syntax. So we just moved our queries from our BI tools into the warehouse. Second, we needed to know how data would get there from all these different sources, from the production database and other sources into the warehouse, and we chose Stitch Data. So we wanted a plug and play tool which had minimal support from engineering, and that's why we went for Stitch Data. We also wanted to know how we could coordinate jobs, and we went for GitLab CI simply because it was very easy to set up, and also the fact that our code lived in GitLab, then it was so seamless to use GitLab CI. Then the most important part for us was how do we manage the models, do we manage the transformations in the warehouse. And we went for DBT, and if I go to more details on why we went to DBT, like I mentioned that we had these pieces of business logic that was repetitive across all several queries. So DBT allowed us to have that business logic that populates or rather that SQL. So DBT allowed us to make that a model and use it in other models. So it was easy for us to update that business logic should it have changed. Then DBT has very excellent documentation, which was something we wanted so that we could make it so clear to anyone who wanted to know what was happening in BI or any other person who joined the team. 3, we wanted to leverage the fact that DBT allows us to use Ginger and Python macros. Then DBT also works with version control, and then most importantly, DBT also allowed us to test our models so that we could make sure that the business logic that has been said is not violated. So if I put all this together, this is what we now have. On the left side, we have all the data sources from our Postgres production database to Google Sheets and our calls database, and this is replicated into the data warehouse using Stitch. So after the tables are in the warehouse, and we normally call them the source tables. When they're in the warehouse, then DBT takes over where it does transformations. So it does, with DBT, we create models, which are simply SQL statements that create data maths in the warehouse. And again, like I mentioned, they are in fact tables and dimension tables. And then now all our database visualization tools from redash to Tableau and other consumers such as data science can now query, or rather can now run on top of these data maths. So putting this into practice, this is an example of an DBT model we have called fact tasks. So like I said, DBT allows us to use Ginger. So it allows us to use this referencing Ginger style of using the source and the ref, where the source means a source table, a table that has been replicated into the warehouse, and the ref refers to another model, so another piece of SQL that populates a table. So if you want to refer to it, you use this ref method. So DBT determines the execution order of these models, such that if you run this model, then DBT needs to run the 2 models that depend on that this model depends on, so that this model runs. So that ensures that our data is always updated. And like I mentioned, DBT has excellent documentation. So given this model called fact task, which refers to 2 source tables and 2 other models, then we're able to see this DAG file with fact tasks at the center. And you can see where it gets the data from these 2 source tables and from these 2 models, where one of the models refers to a source table. So with this DAG, it's easy for you to debug. So if you want to make any changes or improvements in fact tasks, you're able to understand where it's coming from and where it's going. So when you do your changes, you're able to test them and make sure that all the models that rely on the model you are changing are actually running. And also DBT easily allows you to do that. So debugging is very easy. Improving our code is very, very easy. Then, like I mentioned, DBT has excellent documentation, and this is an example of a .yaml file which has a documentation about a model called fact agent earnings. It allows you to have the description of what that model does, and then it allows you to list the columns and have their name and the description and tests on columns. So for instance, here this column is called batch payment entries ID, and the test is that this column should be not null and it should be unique. So once DBT runs and tests the models and all the models pass, you become confident that the data you have in your warehouse is accurate. It also allows us to do custom tests. Like here we have this custom test unique where this column is nullable, but if it's not null, the value needs to be unique. So it allows you to have such a test. So these are what I was calling schema tests, and this next slide shows a custom test where, like I mentioned, the source Ginger syntax means a table that has been replicated in the warehouse, and the ref means that a model that has been built in the warehouse. And so this is a custom test that looks at the amount in the 2 models, and here in the last line, it makes sure that the 2 amounts are the same. So again, this is a business logic, and that needs not to be violated. So we need to make sure that the amount that comes in the tables that are replicated in the warehouse is the same amount that we will be giving out when we are doing when we are doing our analysis. So this test allows us to be always accurate. Then, like I mentioned, DBT allows us to write macros. So we had a challenge where we have a set of columns. So for instance, let's say payments, and we have a column called payment total, and we have 3 reasons for payment. So we have payment and 3 reasons. Let's say payment reason A, reason B, and reason C. So we have payment total and payment underscore A, payment B, and payment C. And the expectation is that payment total is equal to payment A plus payment B plus payment C. But then again, probably later we will have another reason for payment. So we will have payment D. So we wanted a way where we can know pre-hand, or rather we can know all the columns that starts with payment underscore something, and then as long as it's not payment total, if we add all those columns, they should add up to payment total. So we made this macro, which takes in a table name and a regex expression, and it returns a list of columns that match that regex expression in that table. So DBT allows us to do that and then use that list to iterate through and make sure that those sums or all the different reasons for payments add up to the payments total. So this allows us to even scale in terms of the fact that if we get many more payment reasons, then we will always be doing the test correctly, and we will always be catching errors should there be one. So another macro here. So we have indexes in the models that we make in our data warehouse. And Postgres requires our index to be unique. So we wanted to have a combination of the runtime, the column name, the table name, and it was very hard for us, or rather it was very lengthy for us to repeat that over and over again when you are trying to create more than one index in a table. So we made this macro that given a list of columns, it will be creating indexes on these columns. So and down here below is we see the macro in use, where it takes in 3 columns and it will create indexes on the 3 columns. So having said that and having done all that, what difference does it make? So if we compare what we had then and what we have now, as you can see now, we are able to move from this long and nested SQL queries to very short and straightforward queries running on top of, or rather running on top of the maths we have made in the data warehouse, maths which have proper documentation. So should you want to get the documentation for this, it's easily available for you. So this has really improved our queries. It has improved our querying speed. It has improved our accuracy. So therefore, what's next for us? So having done that, we still continue to consider ways in which we could improve this process. So one, we are, as I mentioned, we are currently using GitLab CI, but we are looking at other workflow tools such as Prefect and Airflow, because right now we are also doing some other data transformations in Python, and we want a tool that allows us to manage that better, and also to alert us that to alert us better should we have failures in our data pipelines. We are also considering another data replication tool. I mentioned we are currently using Stitch. We are considering to having tools such as Airbyte. And this is mainly because of our GIS data. So we want a tool that better replicates that data better, so that we can be able to do analytics even on our GIS data in the warehouse. And then, as I mentioned, we are still using a Postgres warehouse. And in the long term, we look into migrating to a more columnar structured database that will allow, or rather that will be better for querying and for using as a warehouse. But for now, we continue to use Postgres database, which is serving us sufficiently. And that marks the end of my talk, unless there are questions.
Thank you, Martin. Now the floor is open for questions. And actually, there is one question in the chat. Martin, can you see it? It's about the replicated table. Kenneth would like to know whenever there is the replicated tables in the architecture, and what kind of such architecture is usable where we only have 10 records per second transaction databases.
Yeah, so the replicated tables are tables from all these other data sources. So for instance, in our case, the biggest is our production database. So where all the tables in the production database are replicated into the warehouse using speech. And yes, it's possible for you to have replicated data where we have 10 records per second, but the tools that are out there for replication allows you to set how the frequency of how you want to replicate. And for us, we have set it at 30 minutes because that's what serves the business, right? So yes, it's possible for you to have that.
Okay, there's another question about if there are good sources to learn query languages.
Yeah, so okay, right now, the query language we use is SQL, structured query language, and there are very many sources out there. One of the most common that I see is W3 Schools, which really has nice examples, and it's also very nice for someone who is starting, or if you are in any level. So you are able to say or to specify what level are you, and you're able to get challenges that will help you become better in querying languages. So yes.
Okay, let me see. Oh, there's a question. Yes. If the system you mentioned is a cloud-based system.
Yes, so we have hosted our warehouse in the cloud. So is our production database. Yes, so they are all hosted on the cloud.
Okay, and there's a question from Brian. If what's the most challenging part when you are moving from ad-hoc?
So in my opinion, I believe it's making that decision and saying, actually, I really want to move. I want to get this stack, and also getting the right stack for you. So the most challenging part is the decision and getting the right stack for the kind of data needs that you have. But once you get over that, then it's easy for you to slowly transition from an ad hoc query to having a scalable ETL.
Okay, I think this is the last question we can cater before we move on to the next presentation. It's from Morris. It's about if Martin, you would like to, you will start the journey again, building such a data pipeline. What would is there something you would do differently from what you're doing right now?
If I was to do differently and right now, so one, I would take some more time to think about the kind of data warehouse I want to use. I know there has been a lot of changes between when we did move to use a Postgres to what we currently have right now. So I would take some more time to think about the data warehouse that I want to move to. To the workflow management tools, that's another thing that I find very key because it determines how frequently you update your data. So I would also take some more time to, and also probably think about the future and make sure that I get a tool that will allow me to do what I want to do now and what I might want to do in the future.
Okay, Martin, thank you very much again.